Guys, welcome back. So this is a proof that's across in the exterior angle theorem. So take a second, review that theorem, kind of getting some familiarity with the rule because we'll probably have to use it actually right here to prove this one. The exterior angle theorem is pretty straightforward. It just says if you take these two angles I'm highlighting 1 and 2, it should be equal to angle 4. If we add the measurements of 1 and 2 together, we end up with angle 4. So as a quick demonstration, if this is like, just say I'm making it up 30 degrees and I'm saying this is 20 degrees, 20 plus 30 is 50, so that angle right there should be 50 degrees. That's all it really says. That's what the exterior angle theorem is all about, and I bet we'll have to use it in this proof. Oops, too much, too fast. Let's try that again. All right, so we have one of these restrictive setups again. We have to prove the measurement of angle 1 plus a measurement of angle 2 plus a measurement of angle 3 equals 180 degrees. In other words, a triangle sum theorem, which means we cannot use a triangle sum theorem in our proof. We have to work around it somehow. And to add to that, add to the restrictions, we're not told really anything at all except the diagram itself is something that we can trust. And so our analysis phase here, our step 1, our analysis, which I don't think I wrote in the last one, A-L-Y-S-I-S, our analysis is really going to be using all the information at our disposal to get to this equation. Now, just like a couple of the other previous ones, our goal here is going to be to build this equation. And so we're going to be very interested in starting with an equation somehow to actually end up with angle 1 plus angle 2 plus angle 3 equals 180 degrees. And again, if you watch one of the previous videos, I know that we all kind of know that the angles of a triangle 1 plus 2 plus 3 have to equal 180 degrees. But since we're being asked explicitly to prove that's true, that's the one fact we can't use, and so we can't leverage the fact that we know triangles have to add to 180 degrees. We have to do it a different way. So let's just get into the analysis. So one thing I noticed right away is that we do have an exterior angle theorem in play here. It never says we can't use that, so that's probably where I want to start. Recall just from the review I did a second ago, the exterior angle theorem says if I take the measurements of angle 1 plus angle 2, it should equal the measurement of angle 4. Okay, and so we can probably write that up. And so this says that the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 4. That's our starting point. That's because of the exterior angle theorem, which since you have that at your disposal, E-O-R-E-M. Okay, so since you have that at your disposal, you're allowed to start there. Now the cool part is it's pretty darn close to what we have to prove to end our statement. So we need the measurement of angle 1 plus the measurement of angle 2. We have the 1 and the 2 right here. The problem is we don't have the measurement of angle 3 yet, and we don't have a 180 yet. But at least it gives us a partial equation to start with, and that's actually pretty darn cool. Since all we have to work with is our diagram, we have to bring in a measurement of angle 3 somehow. Well, if you look at the measurement of angle 3, because of where it's positioned, with the intersection, this actually does form a relationship with the measurement of angle 4. So we have these two lines. Let me grab a different color here. So we have this angle 3 and we have this angle 4, and if you look at them together, they're going to actually form a line. Well, that's important because if I know that angle 3 and angle 4 are linear pairs, okay, linear pairs being two lines that form an angle, I know immediately, because of linear pairs, that the measurement of angle 3 plus the measurement of angle 4 equals 180 degrees. Okay, this is super important because this gives us the other part of our equation. The things that we were missing were the measurement of angle 3 and 180, and now I have the measurement of angle 3 and I have 180 here. The link between the two, if you don't see it right now, is a measure of angle 4. Like that's a missing link that can actually tie these two equations together. So like tying these together may take a little bit of algebra. And so like, if we're going to set up a substitution, like if we're going to take out the 4 in this equation and replace with the 4 in this one, I do have to solve for 4 first. And so using a little bit of algebra, if I just subtract the measure of angle 3, okay, what I'll end up with is a new usable substitutable equation. Because the 3's cancel on this side, I'm just left with a measure of angle 4, and that should be equal to 180 minus the measurement of angle 3. Okay, let me erase that bit again. Try that one more time. Okay, and so what that allows me to do is substitute the measure of angle 4 for this guy right here. We can stick that right into that equation. Well, as a result, I should have the measure of angle 1 plus the measure of angle 2 is the same as 180 minus the measure of angle 3, which is pretty darn close to the equation I have to build. The 3 is on the wrong side, but that's an easy fix. I can just add the measure of angle 3 to both sides. Okay. And then I'm left with the exact equation I had to build. The measure of angle 1 plus the measure of angle 2, which is my original, plus this measure of angle 3 that I'm adding to the side. Those cancel, and so I'm just left with 180 degrees total. And so again, another algebra kind of heavy proof here, which I know we should probably go through that again, and certainly you can go back to the beginning of this video and watch it again, but let me do a quick review. Our goal was to build this equation, 1 plus 2 plus 3 equals 180. And so we needed a starting point, and that starting point was provided by the exterior angle theorem, the one in green here, that says if I take the measurement of 1 plus the measurement of 2, I get the measurement of 4. So we don't want 4 in our equation. We just want 1, 2, 3, and 180. And so we somehow have to relate 4 to 3, but we have that relationship here. 3 and 4 form a line together, linear pairs. We've been doing that for months. So that means they're supplementary, meaning they act 180 degrees. That's good because now we have what we need. We have like a link between 4 and 3. We had to do a little algebra. Move the 3 over to the right-hand side of the equation, giving us this guy, which allows us to substitute in for 4. So by combining the equations together, I have the measure of 1 plus 2 is the same as 180 subtract the measure of angle 3. Add the measure of 3 over, and you have the equation that we have to end up with. And so we're going to start with exterior angle theorem. We got to use linear pairs and supplementary, a little bit of algebra, a little bit of substitution, and then a little bit more algebra, and I think we're home free. And so our statement of intent should definitely reflect that. Let me erase some of this stuff. Okay. And so to prove this equation true, you have to start with the equation given by the exterior angle theorem. That's this guy right here. Let me number my steps. Okay, so that's really step 1 right here. And then you have to use linear pairs to get 4 and 3 into the mix. That's the step right there. And then you had to do a little substitution and a little bit of algebra to build the final equation, and that's that step in the end. And so essentially this is really just a 3-step proof. Now, complicated 3 steps, but just a 3-step proof. For this one, I'm going to switch and do this in a flow style since I haven't done one in a little bit. And also I think it kind of works not so bad for like these multiple equation things. And so we don't really have to talk about our givens because we really weren't given any. And so I'm going to start with this equation for the exterior angle theorem. And so my starting point is going to be here. The measure of angle 1 plus the measure of angle 2 is the same as the measure of angle 4. Okay, and so the reason this is true is because of the exterior angle theorem. Okay, and so also to offset this and separate it, I'm going to go and put a box around this. Okay, so I'm going to switch. I'm going to have a separate thought, and that's going to be my step 2. I know that angle 3 and angle 4 are linear pairs. I don't know why eyes are so tough on this iPad. Which immediately gives us that's a measure of angle 3 plus a measure of angle 4 is equal to 180 degrees. Okay, and that's because the substitution, supplementary angles. Okay, linear pairs by definition are supplementary, so I know those are going to be supplementary angles. And then I'm going to go ahead and do a little manipulation here. I'm going to go ahead and do the subtraction of angle 3 on both sides. So it's kind of like here, it leads to here. The measure of angle 4 is the same as 180, subtracting off the measure of angle 3. We should probably justify this too, but the justification here is just algebra. Okay, we don't have to go any deeper than that. We're using algebraic principles to kind of manipulate our equation, therefore it's just going to be algebra. Okay, and so if I combine these ideas, if I take the first equation and I take kind of like this final form equation, if I take these two and I combine them together, I can have a rewrite, which is it's a measurement of angle 1 plus a measurement of angle 2, which is this part, should be equal to 180, subtracting off the measure of angle 3, which is this part. And so the substitution that I'm doing is really for angle 4. I guess technically you can also call this like the transitive property, but in the end, this is the equation I have, and I'll go ahead and mark this because of substitution. And I think you can also go transition here. I don't think it's discernible in this particular case, but anyway, we're here. Now we're not finished. We should continue this because in the end we want to make this look exactly like our proof equation, which is that a measure of 1 plus a measure of 2 plus a measure of 3 equals 180. But all we really have to do is to take this term and add it back to both sides. And so in its final form, we have the measure of angle 1 plus a measure of angle 2 plus a measure of angle 3 equals 180 degrees. And if we want to do a final justification, we can just say because of algebra. It's also okay to say solving. Solving just implies that you're doing some kind of manipulation. Well, let's not do that. Let's keep it consistent. And so I'll put a final box around here. So we're done because we ended up with the equation that we had to build. And so this one's weird, but again, like we expect a tougher level of proof now. We have to build a couple different equations, and then we have to kind of bring them together algebraically in order to solve this guy, right? So that one's definitely confusing. I would look at that one again. Hate to point it out, but another one that you're just kind of responsible for being able to do, right? So that's this one involving, what is this, in the exterior angle theorem. I'll see you all in the next one.